Tolerance is specification settings on components. So one of the interest is, let's say we have three parts, and then we are making a big part out of these three. So you're adding these three components to make some big part. If you think about car, for example, there are a bunch of things added together to make the entire car. So there could be millions of parts added together. So sometimes the question is, will this satisfy the final dimension that we want to have? So in this case, for example, these three parts, just to have a quick example, these three parts are added together. So we can see the mean value. Let's say these are given in inches, and they're just some linear piece, and then we are going to add them. So 120. So one of the question is, will it meet the specification limit? Let's say the final dimension we want is between 120 plus minus 120 plus minus 10, for example. So the specification limit is basically this. So upper spec limit is 130, and then lower spec limit is 110. So the question is, if we add these pieces together, how many of them will fall in this specification limit? To answer this question, so you have this mean given, the standard deviation given. So you have to first calculate the variance. We have to find the variation for the final assembled component. So find the variation, or I would say variance, which is the square of the standard deviation. So this times this. And then we can calculate. The reason why we're doing this, because we can add variances. However, we cannot add a standard deviation. So that's the final variance of that piece that we are making, adding these three components. So then we can find out the standard deviation as QRT of the variance, square root of this variance. So that's the standard deviation for these three components if we add them together. So now we can find the probability. So in Excel, there is a function we can calculate the probability. We don't have to. So for example, think about this. So if you assemble these three parts, then you'll see the final dimension will distribute normally. Say the upper spec is 130, lower spec is 100, 110. So how many of them will fall within this range? So in Excel, there is a function we can calculate all the area under the curve up to this point, and then subtract all the area under the curve up to this. So the way you do it simply, so what we are looking for is the probability of 110 less than or equal to that part we are producing. So we want the probability in that range. So simply what you can do is, there is a function called norm dist. It will ask for x, which is 130. So first I'm going to find the upper tail probability up to this line, and then comma the mean value, comma the standard deviation, comma cumulative. So this will give me all the probability up to these points, all the way from the left. And then we can similarly find the probability up to 110. So norm dist, and then x would be now 110, comma the mean, comma the standard deviation, and then cumulative for 1 or 2, whatever you want to write. So that's the probability of having an assembled part fall within the specification limit. So if we make 1,000 parts, for example, 800 of them will be within our specification limit. And this is a very useful technique, but pretty simple to do the calculation if you have Excel available to you.